Welcome to Chapter 6 and 7 of AP Calc BC, and I hope this video is primarily used to review most of the material you learned.
Okay, Chapter 6 deals a lot with extensions of the use of antiderivatives, which you learned last chapter. And first of all, the indefinite integral is a new topic. And that is the set of all antiderivatives of an expression. And the only difference between this and regular antiderivatives is that you add on the end a constant c, because when you take the antiderivative, there's really a whole set of them that could be the solution to an equation. So here are some examples. The indefinite integral of 3x squared is x cubed plus c. And the indefinite integral of 3e to the 3x is e to the 3x plus c. And you're using the same rules as you did before with the antiderivatives. You use reverse power rule and reverse chain rule. Next up is differential equations, and this is something that's a little bit different than what you're used to. Instead of being given an equation that is in terms of y. Instead, for these problems, you're given an equation in terms of dy dx, or the derivative of y. And on the right-hand side of the equation, you can have x's and or y's. And the key for these problems, here's an example, dy dx equals 3y. The key for these problems is to separate the variables. So in this case, we only have one variable, but if there had been another term with an x in it, you want to separate, keep the variables, keep the y's on one side of the equation and the x's on the other side of the equation. So here's how to solve this problem, and as you can see, the first step is to separate the variables, as I said, and you can see I divided both sides by 3y. And then after you do that, you have to integrate both sides, take the general antiderivative, find the general antiderivative of both sides. And so you can see the antiderivative of 1 over 3y dy is ln 3y over 3. And on the other side, the integral, the indefinite integral of dx is plain old x. And for these problems, instead of using two separate constants, one on each side of the equation, you combine the constants and just place one c on either side of the equation. Now here's another new concept, and this one is slope fields. And slope fields are just a graph of the xy plane with little segments drawn in representing the slopes, representing the slope of the curve at any particular point. And here I have the example of dy dx equals 3y, and as you can see, the slope of the curve is determined just by y, because dy dx is the slope, and so as y increases, the slope increases, and so as you can see on the graph, the slope of the curve at any of these points is 3 times the value of y at that point. And these slope fields allow us to, if we're given a point at which to start, they allow us to kind of give a rough sketch of the graph of the function just using the slopes given at each of the points.
Okay, so here is an applet for the slope fields that Jimmy was talking about. And as you can see, when you enter different variables and equations in, the slopes change quite a bit. And throughout the course, you will learn about how the graph has symmetry based on the variables such as x or y, and how these variables and symmetry can help you solve an initial value problem. And one of the things you want to notice is the slopes change in some places more than the others, because they're based on the coordinate set. And here's just a sample. It could be kind of fast, but you can always slow it down and look in your own time just to look at how the slopes are changing and learn more about the symmetry in them. Another lesson in this chapter focuses on integration by substitution, which basically means you take a piece of the integrand and then you want to replace it with a variable that makes it simpler for you to solve. And this variable is often called a dummy variable because it usually doesn't stand for anything. And here we'll show you an example of how to use this. So here the integral, you can look for yourself, is 3x squared times x cubed plus 2 to the 1/2, and you let u equal a certain value, so when you simplify it you can cancel out the other number. Here u equals x cubed plus 2, so once you take the derivative and you solve for dx, you can plug it into the original integral, and once this happens you can cancel out the 3x squareds, and once you cancel those out you get the integral of u to the 1/2, which of course is very simple by now, and you just take the integral as normal, and once you take the integral you want to add a plus c and plug in a number to solve it. You want to plug in the u value back into the answer you got, and this just lets you substitute it back, and it's a lot simpler to do than looking at the very messy numbers that you first started with.
So then the final topic is integration by parts, and this one is just a simple formula. The integral of u dv is equal to uv minus the integral of v du. And it may sound complicated, but it's really not, because this is just, you use this formula when you have an expression in the integrand that has some sort of x term and then a term that won't simplify when you take the derivatives. So then the next step is to identify which piece is which, and as I said, the u should be some kind of sort of x term or something that will simplify when you take derivatives, and then the dv should be something that doesn't simplify when you take derivatives. And for u, you take the derivative of u and get du dx, and then move the dx over to the other side of the equation. And then for dv, you take the integral of both sides to get v. So in this example, x cosine x dx, u is x, so du dx equals 1, so du equals dx. And then dv is cosine x dx, and when you take the integral of both sides, you get v equals sine x. So then when you piece it all together, just follow the formula, u dv equals uv minus integral v du. You can see on the bottom there the answer is x sine x minus the integral of sine x dx, and the negative integral of sine x dx is equal to positive cosine x, and then don't forget the plus c on the end.
So another part of this chapter is you want to know population growth and exponential growth. So first off, you just want to know that exponential growth means something grows forever, indefinitely, and y equals a constant times e to the rate times t. And you'll also need to know the population growth model and the logistics curve, because this is a big part of the AP test. And there's two big equations you need to know that are here. And I don't want to go too into detail because these can get a little complicated. The first one just shows the rate, and the second one is solved for p of p based on t. The rate basically says that it's proportion to the amount of members of the population that are alive in a certain period, and the second equation just solves for p so you can find out how many members are actually alive based on the time.